Hello, welcome back to BlenderSushi Live Noding. In this episode, I will explore more about Blender particles using animation nodes and Sverchok. I also will kind of cover this one of my old article about particle nodes. We will be rendering particles in cycles at some point, so particle info nodes in cycle is really important when you're thinking to give it a material, give your particles material, and it works with particle instancer. So we need to cover a little bit about particle instancer as well. You can have a read at my articles, but yeah, I'm gonna try to cover all of those. Okay, let's close Firefox and jump into Blender. Gonna save this basic particle instancing 001. So far, the idea I'm proposing is to use animation nodes to kind of controlling the emitter. We start with the emitter first. I'm just gonna use an icosphere for now. Icosphere has enough of resolutions that we can emit particle from. I can actually use a single point, but I'll use this guy instead. Save. And with icosphere, actually icosphere can have less subdivision. Maybe I'll just use this. And I'm gonna jump into compositing. So as we already know, an emitter object is an object that will emit particles, whether it's from the vertices or from the face or from the volume of the object itself. And if we select that object, this is going to be the emitter objects. I'm going to name it emitter. So this is emitter master, just in case we want to make a instance or duplicates. I'll switch to Blender particle tab and then create a new particles. You can have multiple particles and multiple settings, so just in case you don't know yet. And this is the default particle setting. The other day in the previous live noding, I show you how you can burst particles at one frame, at certain frames. You just set the same number, but today I'm going to kind of emit particles over time. And let's make the particle to start at frame 1 and end at frame 200. It's gonna stop and finish emitting particles, and this is the number of particles we're gonna be emitting, 1000. You can have more, of course. The thing about particle is particles very efficient with a large number, and you can have like a 10,000 or 20,000, doesn't matter. It's really fast. I'm gonna start with a small number first, 1000. And even if we have like 1 million particles per emitter, we can always reduce the number in the display, so we can display like only like 17% of the particles, but it will actually still render like a million of particles, for example. Okay, let's get back to the top. What I really like about Blender particle is it has limitation, but its simplicity and the way you can kind of use instancer is really intuitive. Yeah, so, and you can emit, okay, back to this. You can emit from vertices. You can see the points of the emitter mesh, and then you can emit from face. Normally you emit from face. You can also emit from the volume, so you can see. Okay, that's pretty basic. Now I'll quickly switch on animation nodes, and instead of looking at a static emitter, we're gonna transform our emitter. And I'll turn off always and turn on just update when the frame change. Okay, now currently our emitter is now being controlled by animation nodes. Let's use our favorite nodes, the vector wiggle, and plug in the frame into this guy. I really like this node because it's a super simple, and by doing this you make these objects move as if this has a brain of its own. And yeah, that's more interesting than watching a static emitter. Let's also turn off the grid. Okay, now we have this, and let's investigate the particles that we have at the moment. Currently it's falling down because of the gravity field, and per particle system you can turn on or turn off the gravity. So I will just turn it off here under field weight, so the gravity doesn't have influence on the particles anymore. So now it's as if the particles floating in the air, or actually more like underwater kind of creatures. What's the next thing? I think I can keep it like that. I can turn off the normal and turn off. I can turn off the physics, actually. Turn off the physics and the particles now doing nothing. What will be better is turn off the normal, and supposedly particles just being emitted now, and it's not being influenced by anything else. It doesn't have any velocity. It's just like a static. This is something you can kind of set up depending on what you want. A little bit of motion maybe, and make it like drag or damp the particles, also quite interesting. So it's kind of coming out and then it stops. This is like more natural. Okay, that's the basic of particles that we need for this. Save again. Now let's do a little bit of instancing. Blender particles instancing is super simple. Let's say I'm gonna emit like a bunch of cubes. So I'll use our default cube. I won't scale it yet, but I'll show you real quick. So this is our particles, and this is our gonna be our instance. I'll select the particles, selecting the particles, and then go to under render tab, object, and select our cube. Be careful if you name your emitter, if still name cube, don't select the emitter as your object instance. It will not work. Okay, now we can see the particles is instancing the cube, and they all look the same. But the size doesn't match, because by default particle size is like this number 0.05. This is the default. If we make it 1, now our instance object is that size. So we don't want that. We want it, just keep it small, and then maybe randomize the size a little bit. You can see how interactive it is, and it's super intuitive. I really like it. So you can see the number here also affecting the number up there. Okay, that's very important. Okay, now we have this instance geometry. Although they are all the same rotations, not so interesting to look at. You can, of course, randomize it using, perhaps randomize using Brownian. Although the Brownian affects the position only, so maybe turn on rotations. Now it's rotating. It's quite alright, even though it's basic. It starts to look quite interesting. With our motion of this object, let's turn it on the amplitude in the animation nodes. So now it started to look much more interesting. Okay, that's pretty good. Let's save this again. And what's next? I want to quickly jump into Blender cycles actually, and we start to deal with the color. Currently it's just we have the emitter. Let's give the emitter some material. Emitter material. I kind of at some point I want to make it glowing and those kind of stuff, but we will see. The more important, what I'm interested into color is the instance object itself. So I'm gonna get our cube back. So this guy, the material that you apply into this guy is very important. So let's say I'm giving like a red color. Now all the instance objects is red color. We can change the color here, but it's gonna affect all the particles. With the particles, at some points I was thinking, okay, for each particles I want to give it like a random color. Can we do that? I think we sort of can, but with particle it's different. The particle has first of all, each particle is unique. It has its index number, like from 0 until the end of until the last particles, and the particle also have a age from the start of particles when it got born, get emitted, and then until the particle died. So that's really important. You can actually make like a story just about each particle. So that's how you can kind of control and keep yourself sane. If you have like million particles and you kind of make a list of all the attributes that the particle has and changing over time, and then you try to make the system. I have not made any system that's too complex so far. It's always about making it looks good first. Okay, but anyway, I'm gonna switch on to cycles. Switch to cycles render, and then switch to cycles shader node, and use nodes. Actually, I need to recreate the nodes now. I should have deleted and reapply. So now it should have cycles node. I will use emission, so it's glowing. And for this guy also, I'll just make it black for now. If we render it out or use the material, you can see the color. Okay, let's select this cube and check the material it has at the moment. It's just an emission, so we can make it higher number. There is one node that deals with the particle, is particle info node. And here you have the index of particle, like the number of the first particle being emitted until the last one, and then you have the age of particles. That's really useful. You have the lifetime of particles. I think this is how long the particle will live. And you also have location, size of particle, the radius, and then velocity, angular velocity. Velocity and angular velocity, I don't know much about it. I think angular is like kind of the rotation. Velocity, how speed the particle is doing. Let's investigate all of those. And for that, we need to use color ramp. Color ramp is apparently super useful. I wish that Sverchok has color ramp, and Animation Nodes has, hopefully, I think it has like a color nodes like act like a color ramp, but I wish that Sverchok has something like this. It's very useful. So let's investigate all these numbers, plug into this guy. For the start, let's make it more interesting color, pinkish, and then bluish. Let's control the color using this. Start with the age. Actually, age plug into the vector and the color. Let's see what we have. you can see that the edge actually, we can see the color, the pink color, but it's quickly become blue because the edge, I think, start from 0 and then goes to 1 and then continue on. But I think if we divide the edge using the lifetime, we're gonna get a proper number, the proper, like a normalized value from the start to the end. So as it nearing the death, the particle will just become blue and then it disappear. Currently it's just pop. It doesn't have any transparency, so it just pop out. Okay, so but that's a good to know. You can also like use the H divided by the total number of particles if you like. That's gonna give kind of interesting value. Let's try that. Instead of lifetime, let's divide by total number. We have 1000 particles, so divide it by 1000. So I believe the particles that get emitted near the end will have blue color. How long is particle live? Maybe it's too long. Oh, no, it's dead. It's dead and we're not getting any blue color. Huh, that's weird. Let's go back to this guy. H divided by, maybe, oh, it's actually the index that I need. Index divided by 1000. Now we have the start will have pink color and then the last particle will have blue color. This is another way you can colorize the particles. Okay, that's two important things. So you can have age divided by lifetime and index divided by the total number of particles. And the thing about color ramp in Blender that I just figured out is we can use we can change this. Instead of RGB, we can change it to HHV or HSL. So instead of two value kind of mixing and blending in RGB fashion, we can make it so it's blending in HSV, which is hue saturation value. In HSV world, if we make this guy like red, HSV 0 like this, and make this guy like that, we're gonna have like a rainbow color. Don't make it all the way because one is also red, so make it around that value. So we have like, supposedly we have like a counterclockwise. Yep, that's what I want to show you. Clockwise HSV and this color, and you have this rainbow color. This is index divided by the total number of particles. So we have this the usual like a spectrum color rainbow. Okay, cool. We have like a rainbow cat kind of setup. Still not too interesting. Let's make this emit over 250 frame. You can randomize the lifetime of each particle. Currently it's like 50 frames and then it will disappear. You can randomize it a little bit, so it's gonna look more natural. If you want the particle to have size that gets smaller over time, you actually need to switch. This is a funny thing about Blender Cycles Render is that in this kind of setup, Cycles Render, we cannot select the particles ramping. If I go back to Blender Render, I show you what I mean. I select the particles system and then I switch to texture. Now we have these texture particles that we can use to control the size of particles. Just change this to particle as texture coordinate and and affect the size. So you see now as the particle being emitted, it grows and then it disappears. You can probably make it the other way around. In the color, switch to ramp, and then here just switch it from white to black. So when it's get emitted, it's like so the size is actually 1, and then it becomes smaller over time. That's one way you can approach particles fade in, fade out. For fading out, we can now switch back to Cycles render, and then you see the size, particle size still affecting the particles, which is good. Save this and continue. So with the particles, let's get back to the materials. We can see it's changing color. What if we want to also make it fade out over time? You can use also color ramp. And it should, when it's doing a fade out, should be start from white and then stay at white color for a while and become black and fade out. We can do it with mix shader, apparently. Mix shader. So we can have like a transparent shader. If we give it a transparent shader, let's see, color. Okay, this plug to that guy. This guy plug into the surface. Particle should be transparent, but it has color, so yeah, that's pretty interesting that black transparent BSDF is actually still showing up. Maybe I need to render it out. Yeah, I think it's actually affecting the alpha. Let me try something real quick. So if we plug the emission into this guy and then transparent into this guy and affecting the shader with the color ramp, age divided by lifetime, we should in theory get the result that we want. Let's try that real quick. Texture, not giving anything. Material, didn't show. Rendered. Maybe transparent. Maybe this should be in the vector. This divided by that and the factor. I think maybe the color should go into transparent black. Are we getting transparency? Well, can't see anything. Let's switch to this guy and then test it. It's transparent BSDF and then diffuse BSDF and then mix the shader. This guy and that guy. Diffuse maybe blue and then have a look. Maybe emission. Yeah, it's doing the transparency thing. Maybe have a bit of environment so we can see what's going on. Now we are inside this cube. Let's get it like, let's do it like this. Select this guy, emission, high emission, maybe green. If I'm doing it like this, it's gonna be pretty slow. Oh, apparently the transparency white is actually a full transparent and black is actually diffuse. That's why I think that's what I did wrong in this case. Okay, let's get back. Select our particle material and switch this thing around. White is opaque, black. Oh, white is fully transparent, black is actually opaque. I think that should do the job. Alpha goes into vector. Stop this. Let's get rid of the environment. We're getting just black. Maybe I did something wrong here. Maybe this should go in there. And the vector should be this guy. Yeah, I think this is doing the job. Clamp the value. Well, I think it's doing its job. It's just we can't see it because of the size is getting smaller as it goes. As the particle is dying, it becomes smaller. Yeah, I think that's let's see what we have covered. Let's write a quick note. Blender particle system. Simple. We cover the emitter, animated by animation node, and we cover instancing, and then we cover particle info node in cycles, and we can see how particles being affected by the age divided by lifetime, and then index divided by the total number. Let's see what else. We know that also particle size can be affected by ramp in Blender internal. Let's do something with Sverchok. Actually, now we know that okay, we have where's all particles? It's our cube. Okay, this is our original cube. Let's make this, let's simplify this. Instead of all this, I'm gonna use just a single shader. Emission shader. Give it color red. Now it's all the particle is red. I'm gonna duplicate this guy and another one, and then this I'm gonna give new material. This is gonna be emissions and give it a color blue, and this guy is gonna be another new material, emissions, and this is green. Okay, 3 color, red, green, blue. And I'm gonna group those. Control G, see they are grouped. And now with the instance of this guy, I can simply change the objects into the group and select the group. Now what's gonna happen? The objects being instance is all in a, it's a randomly selected from this guy. I have not covered this yet. Whole group, pick random may be useful. Global rotations, this is pretty basic, but basics and simple is really good if you're just starting out with particles. Now we are instancing based on this guy. Now to do the instancing, actually instead of cube, we can really use Sverchok. This is what I'm proposing. With Sverchok, you can easily, right, create like a random mesh as instance object. So I'll restart Blender real quick, restart fresh. With Sverchok is always a good idea. Save the blend file and then let it crash, reopen Blender and start working in Sverchok. It's a funny little bug. Let's see what we should do in Sverchok. You can create like a kind of flower pattern design, or I don't know, let's have a look. Sverchok generators, circle maybe, random circle, even circle. I always often goes blank with Sverchok because so many possibilities. Circle and polygon. That's our circle. We can randomize. Actually, polygon is more interesting. See, we can use circle and randomize input vertices and randomize this guy and give it different seed, and we have that abstract pattern. Sometimes too abstract. But let's just use polygon. Hexagon is n-gon. I think it's n-gon. Vertices and polygon into the viewer B mesh, and the output we want it to be grouped as well. Don't forget. And we want to randomize it slightly. With the seed here, we can have random number. Random number generator. Give it a random seed. How many do you want? 10? Maybe plug in there. Now we have 10. That's how I will approach Sverchok for Blender particles. I might repeat this in a future LIVENODING, and then let's see what we can come out with, because this is really super useful. You see, now we have this random object, random pieces that we can play with. Increase the radius back. I think I almost forgot something. Perhaps you can also use other, like the scripted node and get a flower, spiral, Fibonacci. Super formula, that's interesting. Pedal sign. Yeah, pedal sign also interesting. But this only gives the edges. Unless we use the UV connection. Well, I think I have to think on that first. Let's just use this guy. So select the Blender particles, and then with the group for the instance, just select our group alpha. Now we have random particles being instanced. You see, and let's increase the size and randomize further. I think this is really cool. It's give a, you have like quite random instance, and if you think that's not enough, just increase it here. Maybe give 100 randoms, because eventually you will hit the points where, okay, you have enough random that you don't care too much, but you just look, just the instance objects looks natural. Here, this is like all the pieces, and you randomize the objects, and currently it doesn't have any materials. I forgot. I'm gonna select this guy and give it our material. I think it's the red color. Select this, select that, Control L, link the material, go back to this guy, and then check it out. We only have red color. Back to the material node of the instance, plug in our mix shader. Now we have the spectrum rainbow color. Yeah, you can imagine this like a, I don't know, currently it's a bit abstract, just random pieces being emitted. But this, even if you know only this knowledge of particles, you can actually create quite a cool looking result. Let's say we are increasing the number of particles. Instead of 1000, have it 5000, and make it more random. You can use turbulence and all kind of stuff. Randomize the velocity. What else? Velocity random, angular velocity on, and dynamic. See, now they're all moving stuff. If it's for motion graphics, sometimes this is a good start. Sometimes I'm not so into the realism too much. I like more like abstract motion graphic stuff. Maybe that's more my calling. Okay, this instance is random enough that our eyes doesn't care. We cannot tell. Okay, that's actually the same pieces. No, you won't be able to tell that. So that's all right. That seems pretty good. We can do furthermore, like back to our wiggle here, make it move faster, perhaps. Switch to 3D view full, and now, okay, that's actually too fast. 4 is enough. Okay, that's almost like real speed. Switch to materials, texture. Let's stop this and switch on. Where's our DSL SL? Seems to work right here. Maybe hide the node editor and it should be a lot faster. There we go. Just for fun exercise, if you want to perhaps have multiple of particles, you can do that on your own. And also maybe make this emitter change in size over time. That's the thing you can do easily with animation nodes. Sverchok can do like a it can generate, Sverchok can generate random instance, so play around with that idea as well. You can have maybe make like random butterfly coming out of this emitter. I always want to do like a animated butterflies procedurally. That's one of things we can do. Yeah, I guess this is all right. This is still pretty basics, but it's pretty interesting nevertheless. And if this is the first time you are using Blender particles and animation nodes and Sverchok, this is yeah, it's gonna be fun. Oh, by the way, I think the color, I know what's wrong with it. It's the index divided by total number. Currently is wrong. It should be 5000. Back to our node editor, material, select our, this is I should name it properly, instance material. This not 1000 but 5000. This is the total number of the particles. So now material 3D view full and turn on the timeline. You should have proper color from the beginning and to the end, and then the particle itself also slowly disappearing in size. Yellow, green, and blue. Okay, cool. It's working perfectly. So that's all for this live noding. Hopefully you find this video useful for your exploration in particles for your job. I guess I'll see you in the next video. Thanks again for watching. If you have any question, just leave